Hello everyone, welcome to Super Coaching UPSC by Textbook. This is Venkatesh, your faculty for Geography. Students, as part of the Geography syllabus, certain basics are very important, and such questions are very much repeated almost every 3 years. One of the important topic in climatology is about how do you think that the atmosphere is being heated up and cooled up? What are the methods of heating and what are the methods of heating and cooling of the atmosphere? So, advection, conduction, convection, to a certain extent even terrestrial radiation are the methods through which our atmosphere gets heat. The source is always the sun, and that heat is being distributed across the planet Earth through these four methods. We would like to understand in this session about the same four parameters, right? Just a minute. Let me see if you have any doubts. And that heat is being distributed. Yes. Okay. So that is the process. Heating and cooling of the atmosphere. The four methods: conduction, convection, terrestrial radiation, and advection. Let us try to understand all these things. Okay. So the first thing, for the heat and the cool of the atmosphere, what is the source of heat for the planet Earth? Sun. Sun is the source of heat. From the sun, we get the heat, and thereby it will be distributed in all these four methods, especially conduction, convection, advection, and say terrestrial radiation. Terrestrial radiation. Let us try to understand each one of it, right? So, sun is the ultimate source of atmosphere heat and energy, but its effect is not direct. Four common types of energy transport are involved in heating of the atmosphere, right? So, let us try to understand the first one, conduction. Conduction. Have you ever seen your water bottle, or rather, the best example is you take a bowl of warm water, another bowl of say cold water. Try to distribute it. Try to pour one one bowl of warm water into the bowl of cold water. You will be definitely knowing that there will be molecular movement and there will be distributions of heat within the water. A very simple thing which we do in our whenever there is more hot water in our whenever we are drinking some kind of hot water and we wanted to reduce the temperatures, this is what we will be doing. We will be diluting it by adding more normal water. What is that process of distribution of heat in that water molecules? Conduction, right? So, conduction is the transfer of heat among the molecules. Heat transfer between objects in contact is what we call it as conduction. How do you think that conduction is happening here? The mechanism is heat flows from warmer to cooler objects until equilibrium, right? Until equilibrium. When you have a warm water in one glass and cold water in another glass, and when you are trying to distribute it, it will be distributed until the entire water body's temperature is one and the same. Such distributions of heat through the molecules of that object is what we call it as conduction. The same thing is happening every day through the planet Earth. When you find the heat from the sun's rays are hitting the Earth's surface. From the Earth's surface, the lower layers of atmosphere, don't go by the layers means here the typical thing like stratosphere, atmosphere, troposphere, stratosphere and all. It is the few meters, the few layers above the Earth's surface, right? There, you will be definitely seeing that when the Earth's surface is acting as a radiating body, the few air molecules which are excuse me, which are in contact with the earth, they would be getting the heat. That is what we call it as conduction. So you can see here, if this is the surface of the earth, few layers of the earth are being heated up. This process is what we call it as conduction. Definitely, do you really think that this is the major source of heat of the atmosphere? Definitely not. It has a minor role in the atmospheric heating, but definitely it is a decent thing. And we all know that air is a poor conductor of heat. Air is a poor conductor of heat. Right. So this is what we call it as conduction. Minor role in atmospheric heating, and air is a poor conductor of heat here. Now, once you have understood the conduction process, let's go to the next one. Convection. Now you see convection. Convection. Have you heard about convectional rainfall happening at the equatorial areas? Right? That process is called as convection. Let us try to understand this. Now you see, when the atmosphere is heated up because of the vertical rays of the sun, say at the equatorial area, what will happen to the air molecules? Just like any other thing, it will also expand by heating. Air molecules expand by heating. As the molecules expand by heat, they become lighter, just like the thing. So what is happening? Air molecules here expand by heating. Air molecules expand by heat. Once they expand by heat, they start rising. As they expand by heat, first of all, they become lighter. Air becomes lighter and they start rising. As they rise, they keep on rising until to the tropopause line at the equator, which is almost around 18 kilometers, 16 to 18 kilometers at the equator, because of more expansion and rising. As they expand and they rise, you would see that the because of this process, whatever the heat air which is happening, it will rise, keep on rising, and will reach until the upper portions of the first layer of the atmosphere, that is the troposphere. So if this is the surface of the earth, as the air molecules will rise, they reach until the tropopause. And you know that this convection is very dominant in the regions of equatorial areas. In our part of the world, especially very dominant in the summer. Have you ever seen rainfall in the afternoons in the summer at around 3 p.m., 4 p.m., right? What is the event? Simple. Since morning, there is intense heat across the atmosphere during the summer months. As there is intense heat, air molecules expand by heating, they become lighter and they start rising. Whatever the water vapor which is being evaporated here, water vapor which is coming through the evaporation of the water bodies on the earth's surface at this point of time, when there is decent amount of water vapor and all, when the process of precipitation begins, it actually happens at around 3 o'clock, 4 o'clock, because in the morning there is more heat. Air molecules are expanding and rising with the water molecules. As they rise and all, that is when you will find this is happening. You will find the cloud formation, condensation, and the rainfall. This process is happening because of this process called convection. So what is the thing? Mechanism? Heated air rises, expand, move upwards. Similarly, what if there is a cool air? Cool air descends. Have you ever observed? Why do you think that our ACs are always much cooler? Rather, what is the right word? That's not the question. Yeah, the right thing is, when you have our air conditioner, usually we will have our ACs being located at the top position of a room. See, They are not located at the bottom position of a room. Why do you think that they are located at the top position of a room? The reason is simple. The AC releases cool air. Cool air comes together, contracts. They come together. They become denser. As they become denser, they will sink. They'll fall down to the lower portions of the room very, very quickly. And ideally, imagine here there is an AC. As the air molecules, cool air coming from the AC, come onto the room, occupy this portion, they become very, very cooler. They condense, they come together rather. As they come together, they'll start falling down. In that way, the room would be quickly cooled down. That process is also convection. So what is the thing? Air molecules expand by heating, contract by cooling. As they expand by heating, they become lighter. As they contract by cooling, they become, what do you say, denser. Dense air sinks down, lighter air rises. What is happening here? Whenever there is a heat, the air molecules also move up and down in the atmosphere, and that is how they are distributing the heat in the atmosphere. This process is what we call it as convection. Simple point. Vertical heating of atmosphere is called as convection, and they are confined to the troposphere. So you have discussed now the process of convection, the process of conduction. This convection is very dominant in the tropical and the equatorial areas, very dominant in the summer months, and that will help in distributions of heat across the regions of the world. This is what we call it as convection, a very, 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 very important topic of how atmosphere is being heated up and cooled down. Moving forward, the next topic, you can see here, this is the surface, air molecules coming together and they rise. Why do you think that they are rising? Because of the process as suggested called convection. Let's go to the next one, advection. You can see here, this is the surface, this is the thing. Now, in the summer months, we all had heard about the wind called Lu, hot winds. Lu. When there is unequal heating of the Earth's surface, unfortunately, there are certain regions which are heated up more and certain regions which are not so heated up. When there is unequal heat, definitely to balance it out, there would be the local winds. There would be winds which move horizontally across the Earth's surface, right? If you talk about the global wind systems, be it the seasonal wind systems, be it the local wind systems, there are sources of balancing agents of heat. What are winds? Winds are balancing agents of heat. How do you think that they balance it out? Simple point. There is more heat here, there is lesser heat here, and there would be movement of movement of the air molecules between these two portions, and slowly this entire region, the temperatures would be balanced out. That process is called as advection. What is the mechanism? Horizontal movement of air transferring heat. What is the mechanism here? What is the definition? Horizontal movement of air transferring heat. What is the mechanism? Warm or cold winds carry temperature characteristics. They influence the local temperature based on wind origin. They are more important than vertical movement, right? Because they are moving horizontally across larger amounts of periods of larger regions. Have you heard about this statement which you have said in n number of times? Excuse me. Himalayas protect India from cold Siberian air mass. Himalayas protect India from cold Siberian air mass. Somewhere in the Siberian region of Russia, there is an air mass which is coming up all the way across the continents and reaching the Himalayas, and Himalayas are acting as a barrier. How do you think that the transfer is happening? Simple point. There is a large uniformity of temperatures and humidity in the regions of Siberia during the winter months, especially December, January, February. By Jan, Feb, you would see that the such wind systems move towards as they start moving, they will be transferring the cooler temperatures from their portions towards different parts in the Central Asia and towards the regions of India. That is what we call it as advection process. So, this advection process is very, very important in terms of transfer of heat, especially in the temperate regions of the world. Where there is not that much heat for convection to occur. How do you think that the atmosphere is being heated up? How does the distribution of heat is happening here? It is through the advection of process. Remember, there are some kind of wind systems called as westerlies. Westerlies in the temperate parts of the world. Often, in the climatological terms, we use this word. Westerlies are the dominating agents of wind system. Westerlies are the dominating source of, what do you say? Westerlies are something like controlling factors of the temperate regions. They control the weather of the mid latitudes. What is the statement? Westerlies control the weather of mid latitudes. One of the method of controlling is, because in relative terms with the tropical part, heat is not that high like you find at the equator or the tropical part. This is where you will find the vertical wind system, the horizontal wind systems are the main differences of weather, and that is how they control the weather of the mid latitudes. In the tropical areas, there might be tropical storms like cyclones, typhoons, tornadoes, whereas in the temperate part, yes, there might be temperate cyclones occasionally, but the major distribution difference agent of weather differences are advocated by westerlies. That is because of the process of advection, right? So, advection is the one which controls the weather of the mid latitudes. A quick review of all these three things: conduction, convection, and advection. Simple point. You see it here. Conduction. Heat is transferred to that part of the atmosphere closer to the hot surface of the earth. So, when the earth's surface is acting as an radiating body, the molecules surrounding it would be intensely heated up, and those are the ones which are getting the heat from the source. Imagine a hot pan. When there is go to the kitchen, take a hot pan, put your hand very near to it. You can feel the heat, no? Right? Not during the, when the pan is being heated up. When the pan is being heated up, the air is rising, that is convection. But after closure, still there is some kind of heat on the pan which will be distributed towards the surrounding areas. That is conduction. During when the stove is lit by fire, when you see that there is fire coming up, and when the pan is being heated up, that process is convection. And after the pan is being heated up, imagine put your hand there, that is conduction, right? Then imagine there is some kind of, then you will find that where there is some kind of a breeze which is blowing across your home, say from one room to another room. Ventilation is whenever it is good. When the winds are blowing, definitely the temperatures are being distributed. That is what we call it as advection. As you can see, conduction very, very nearer to the surface, very nearer to the surface of the hot, that is maybe here the sun, maybe here it is we're talking about the earth's surface, maybe there is a volcano, very, very less at certain times. Air being rising in the atmosphere to larger portions of the atmosphere, that is the convection process. So this is vertical, this is horizontal advection. So these are the three dominating methods through which our atmosphere being heated up and cooled down. There is also another one, terrestrial radiation. Terrestrial radiation. What is this? Terrestrial radiation. There is something called heat transfer through the electromagnetic radiations. Heat transfer through the electromagnetic radiations. So what is happening? The sun is a source of heat. The sun is a source of heat. The sun transfers its energy through the electromagnetic radiations, different waves, wavelengths, electromagnetic spectrum if you know it. Now, there are molecules, the atmosphere is not like, it is formed out of variety of things. Can you tell me what are the things which are formed, which are composed in the atmosphere? What is the composition of the atmosphere? Any one of you? Can you tell me what is the composition of the atmosphere? Come on. Tell me the composition of the atmosphere. Gases. Atmosphere comprises of gases, dust particles, clouds, right? The water vapor, gases and the dust particles. This is what the atmosphere composed of. Now, when the atmosphere, imagine there is a gas, ozone, in our stratosphere. What is the nature of the ozone? So you take something called as ozone here. Ozone in stratosphere. Ozone is largely opaque to the incoming solar radiation. It is absorbing. See, whenever the electromagnetic radiations are moving, the waves are moving, depending on the particle through which it is interacting, the particle has three options. Depending on the wavelength of the waves where they are moving and the particle's size, you would see that either there would be reflections, or there will be absorptions, or there will be transmissions, right? Or rather transparency. For example, when the electromagnetic radiations of the UV radiation, ultraviolet, is traveling, ozone is largely, it is not transparent, it is absorbing. If the ozone is not having the characteristic of absorbing the ultraviolet radiation, such ultraviolet radiation would have been hitting the Earth's surface. So ozone as a nature is what? Absorbing, not transmitting. But ozone is largely transparent to, say, visible spectrum. So what is the thing happening? The atmosphere particles will be having something they absorb, something they radiate, reflect, scatter, something they, are transparent. Because when you see, when the Earth's radiation is released, when the sun's radiation is released, the electromagnetic radiation, the long wave, when the sun's radiation is released, say the larger energy particles like gamma rays, X-rays, they are largely absorbed in the space. They are not reaching our Earth's atmosphere. So our Earth's atmosphere is not reaching, getting such kind of things. Whatever the UV part is there, that is absorbed largely in the atmosphere, and then the remaining portions are reaching the Earth. Once the radiating part reaches the Earth's surface, the Earth is acting as a radiating body. Earth acts as a radiating body, and that is where it reflects the long wave radiation. And this long wave radiation is the one which is absorbed by the, agents like water vapor, greenhouse gas, and all those kind of things. This is what we call it as terrestrial radiation. So you see, sun emits short wavelengths, that is high energy. The Earth is receiving such energy from the sun. The Earth acts as a re-radiating body. The long wavelength, that is what we call it as terrestrial radiation. Atmosphere which comprises of water vapor, greenhouse gases and all, absorbs such kind of long wavelengths and thereby they are heating it up. So, if you see it, such kind of atmosphere, water vapor and greenhouse gases which are there in our atmosphere, see, you do find that the water vapor, greenhouse gases are all there in our atmosphere. When the incoming energy is there, they are largely transparent. But when there is outgoing energy from the Earth's surface, they are not transparent. They are absorbing. When they absorb, naturally they will have heat. For example, ozone is absorbing the UV radiation. Definitely you will find some heat there. There is some heat in the stratosphere. It might not be that level, but definitely it is not a cooler layer of the atmosphere. The reason is simple. There is some heat which is being absorbed by the ozone, the ultraviolet radiation. That's what you can see here, this diagram. Sun energy, some part it is being scattered. You can see here this is being scattered, some being transparent, absorbed by the earth. From the earth, once again as they move, they will be absorbed by the greenhouse gases and all, and that is how the atmosphere is getting the heat. These are the four methods through which how the atmosphere gets its heat from, right? So, terrestrial radiation is through the energies of the sun and thereby from the earth's surface, which is acting as a radiating body. Hope you all have understood the methods of heating and cooling of the atmosphere. If you want the PDF file of this, you can get it in my Telegram channel. If you have any doubts about this concept, please don't hesitate to ask your questions in the comment section below this video, or you can always ask me any doubt in the Telegram channel. Basically, Telegram channel is meant for interaction between us, among us, so that your doubts are being resolved. That's it then, all of you. Thank you. Have a good time. Hope you all have understood this topic well. Keep learning. Jai Hind. Thank you.